Now what is the Laplace transform of sin of AT? So what is the Laplace transform of sin of AT? So we know that sin of x is equal to e power iota x minus e power negative iota x divided by 2 iota, and cos of x is equal to e power iota x plus e power negative iota x divided by 2. This is the two function trigonometric function, a conversion of trigonometric function to exponential function. So what is the Laplace transform of sin of a t? So Laplace transform of sin f of t is equal to Laplace transform of f of t, and the f of t sin of at from 0 to infinity sin of at e power minus st dt. It is the original function. So sin of at is equal to sin of e power iota at minus e power negative iota at divided by 2 iota e power minus st from 0 to infinity dt. So it will be 1 over 2 iota. 1 over 2 iota is common, so it will be integral from 0 to infinity e power iota at minus st minus integral from 0 to infinity, here is dt, from infinity integral from 0 to infinity minus e power iota at minus st dt. So it is 1 over 2 iota, and integral of this function is e power t into iota a minus so divided by iota a minus so from 0 to infinity minus e power here is t common, so t into iota minus iota a minus s divided by minus iota a minus s from 0 to infinity. So if I applying the upper and lower limit, then it will be 1 over 2 iota, and this is iota a minus so, and if I apply the upper and lower limit, then it will be 0 minus 1, e power negative infinity equal to 0 and e power 0 equal to 1 minus if I common minus from this denominator, then if this minus will be cancelled out with this, then it will be plus, so it will be iota a plus s, and if I substitute infinity here, then it will be 0, e power negative infinity equal to 0 and e power 0 equal to 1, so it will be minus 1, so 1 over 2 iota, and it will be 1 over s minus iota a minus 1 over s plus iota a. So if I taking LCM of these two fraction, then it will be s square minus iota a whole square, so iota square equal to 1, so minus 1, so this minus with this it will be plus, so s square plus a square, and s plus iota a minus s plus iota a, so minus cancel out with this plus sign, and iota plus 2 iota, iota a plus iota a, it is 2 iota a divided by s square plus a square and 2 iota, so 2 cancel out with this 2 and iota cancel out with this iota, so a divided by, so I can write it here, so the LCM of these two fraction 1 over 2 iota, 1 over s minus iota a minus 1 over s plus iota a, so 1 over 2 iota, and LCM is s square and iota a whole square, so iota square a square iota square equal to negative 1, so negative with this negative is plus, so it will be s square plus a square, and it will be s plus iota a minus s plus iota a, so s cancel out with this, and iota a is equal to 2 iota a divided by 2 iota into a square plus a square. So 2 iota cancel out with this 2 iota, so it is a divided by a square plus a square. So the result is this, that Laplace transform of sine of at is equal to a divided by a square plus a square.